All right, welcome to our sixth video of Unit 7. This is to talk about neutralization reactions. We're finally talking about what happens when you mix an acid with a base. So, in general, acids and bases react to produce a salt and water. Okay, going back to that actual old equation I showed you a while ago, we had hydrochloric acid and sodium hydroxide. These reacted to form water and salt. Okay, now, technically this is what we typically call salt, but it will actually produce a salt. So some kind of metal bonded to some non-metals. Not always table salt. But acid, base, water, salt. The complete reaction of a strong acid and a strong base produces a neutral solution, meaning you can actually mix hydrochloric acid and sodium hydroxide. If in the same concentrations and the same amount, you will have a neutral solution, meaning you just made salt water and you can drink it. We're not going to in our lab, but you really could. They'll neutralize each other. Thus, we typically call that type of reaction a neutralization reaction because it neutralizes the solution. A reaction between an acid and a base will go to completion, meaning we'll actually convert all of it into products as opposed to forming an equilibrium, only when the solution contains equal number of hydrogen ions and hydroxide ions. That's why I said in the previous, you need the same amount of the same concentration of each acid and base that you are using. Otherwise, you're not. If you have too much acid, you'll end up with an acidic solution. Too much base, you'll end up basic. If they're the same amount, it'll be neutral. Our balanced reactions of acid and bases then help us determine what ratios we need to add acids and bases. If we balance it and we find that our coefficient for our base is 2, that means we're going to need twice as many moles of base as we do acid. Now that's not always milliliters, that's not always concentration, it's the amount of moles needed. So we'll be working on that in just a bit. So, here's your first example. How many moles of potassium hydroxide are needed to neutralize 1.56 moles of phosphoric acid? I'm going to let you work on this for a bit, but as always, start by making a balanced equation and work from there. This goes back pretty much to stoichiometry. So, spend a few minutes, come back in a bit. Alright, so hopefully you actually made an equation. You should have gotten KOH plus H3PO4 produces pretty much H2O and K3PO4. You may not have quite caught that K3 since it's actually 1 plus. If we have K3 and let's see, we're going to need 3. Going to need 3 of these and 3 of these. All right, if we have 1.56 mole of phosphoric acid, I'm wondering how many moles of potassium hydroxide we need. Well, 1.56 basically times of H3PO4. 3 moles of KOH and 1 mole of H3PO4. That gets you 4.68 moles. That's it. Now, of course, they get a little bit harder. But the thing I want you to realize is that gets us the equal amount of moles. So most of the time, they're going to give us a concentration and a volume. We need to first get those to moles, and then it just turns into stoichiometry. So, there you go. All right, for our last example. Okay, this one's also dealing with moles. But how many moles of sodium hydroxide are required to neutralize 0.20 moles of nitric acid? As with before, try it. Come back in a bit. All right, so when you actually use this, really ends up balancing with one coefficient, or just one such a coefficient. That means 0.20, 0.2 moles of this, which basically means we just need 0.2 moles of this. All right, thanks for watching.